Good morning students and welcome to chemistry class. Today we are going to start new chapter of chemistry, that is chemical kinetics. We know that during a chemical reaction, reactants are converted into products. But suddenly some questions come into our mind that whether a chemical reaction is possible or not. And if the reaction is possible, then how fast does a reaction proceed? To understand and predict behavior of a chemical system, one must consider both thermodynamics and kinetics. We read thermodynamics chapter in our previous class, which help us to predict whether the chemical reaction is possible or not in terms of gives free energy change. If gives free energy change comes out to be negative for a particular reaction, then the reaction is possible. But if delta G comes out to be positive, then the reaction is not possible. So, thermodynamics helps us to predict the feasibility of a process, but does not tell anything about the rate at which the process takes place. Okay? And in chemical kinetics, we can predict the rate of a particular reaction. The branch of chemistry which deals with the study of the speeds or the rates of the chemical reactions, the factors affecting the rates of the reactions, and the mechanism by which the reactions proceed is known as chemical kinetics. Now, let's start with rate of reaction. The rate of reaction means the speed with which the reaction takes place. Just as the speed of a vehicle is expressed in terms of distance travelled per unit time, the speed or the rate of a chemical reaction is expressed either in terms of decrease in the concentration of reactant per unit time or increase in the concentration of product per unit time. So, the rate of reaction is the change in the concentrations of reactants or products per unit time. And for a hypothetical reaction A to B, the concentration of reactant A decreases with time and the concentration of product B increases with time. And this graph shows that the change in the number of A and B molecules in the reaction as a function of time period. Okay, and as we know that as the reaction starts, the concentration of the reactant A is more and the concentration of the product B is low. And when the reaction proceeds, the reactant A consumed during the reaction. Due to this, the concentration of the reactant decreases with the time and the concentration of product B increases with time as products are formed during the reaction due to chemical change. And rate of reaction can be expressed in terms of reactants as well as in terms of products. Mathematically, the rate of reaction in terms of reactant is equal to change in the concentration of A with change in time, and with respect to B, it is equal to change in the concentration of B with the change in time. And if A1 and B1 represent the molar concentrations of reactant and product respectively at time T1 and A2 and B2 are their respective concentrations at time T2. Then changes in concentrations of the reactant and product will be del A and del B. Del A is equal to A2 minus A1 and del B it is equal to B2 minus B1. And the time interval is del T which is equal to T2 minus T1. So the rate of reaction in terms of reactants or product will be written as minus del A by del T and del plus del B by del T. And note it down that this negative sign signifies that decrease in the concentration of reactants. Always, and note it down that rate of reaction is always positive. It doesn't mean that the rate of reaction is negative. It only shows that rate decrease in the concentration of reactants, and the positive sign shows that increase in the concentration of product. Okay, and the rate of disappearance of reactant is equal to rate of appearance of product. Okay students, thank you students and have a nice day.